Hello and welcome to the eMath Instruction Algebra 2 Regents Review. My name is Kirk Weiler, and tonight we're going to be doing the June 2024 Algebra 2 Regents exam. Now, if you don't have a physical copy of this exam sitting in front of you, I would suggest pausing the video now, going to any browser, type in Algebra 2 Regents exams. It will take you right to the New York State Education Department page where you can download this exam. It's just a lot more helpful for you if you've got the physical exam sitting in front of you. Now, the other thing that I would also advise is that you have some kind of graphing calculator, because we're going to be using one, I think it's like on problem 2, we're going to already be using it, all right? So it's really essential. Tonight I'll be using the TI Inspire calculator, all right? But of course you can use whatever calculator is most comfortable with you and what you've been using all year long. All right, so let's jump right into it and get going with the first set of problems. All right, multiple choice. Let's take a look at problem number 1. Which expression is equivalent to x plus 3 quantity squared plus 4 times x plus 3 minus 5? All right, so this is clearly a factoring problem, and I can tell that because 3 of my choices are basically the product of 2 binomials. And then I have choice 4, which is kind of weird, but I guess it could be choice 4. Now, what they expect in Algebra 2 is for you to be able to use your basic types of factoring to be able to factor things that are a little bit more complicated. When I look at this particular expression, what I want to be able to see is the structure of the expression. Specifically, I have something squared plus 4 times that same thing minus 5. I can make this problem easier to deal with if I do a little substitution, and here's what I mean by that. I'm going to take some other variable aside from x. I'm going to use the letter m, you could use the letter y, whatever. I'm going to say m is equal to x plus 3. And so what that means is that I'm going to be factoring m squared plus 4m minus 5. And this is just a classic trinomial factoring, right? Nice leading coefficient of 1. And I'm looking for 2 numbers that have a product of negative 5 and a sum of positive 4. So that's going to be m plus 5 and m minus 1. All right? And really, if I was back in Algebra 1, this would be basically what the question would be. But now what I'm going to do is I'm going to take that m in both of these parentheses, and I'm going to back substitute in x plus 3. So what that's now going to look like is the following. It's going to look like x plus 3 plus 5 times x plus 3 minus 1. I can simplify this into x plus 8, and I can simplify this into x plus 2. And that gives me choice 2. The Regents loves doing this, and this is what they get at when they say that they want you to see the structure of an expression, right? So even though this is a little bit more complicated, as soon as we really realize that it has this structure, it's fairly easy to factor. Let's take a look at problem number 2. Which value to the nearest tenth is an approximate solution for the equation f of x equals g of x if f of x equals 5 divided by x minus 3, and g of x equals 2 times the quantity 1 plus 3 to the x? All right, a couple things on this, right? When you see something where it asks you for an approximate solution, what they are really getting at is a skill that they want you to know, especially at the Algebra 2 and higher level, which is how you solve an equation, specifically this equation, graphically. All right, and specifically what we want to do is we want to take our graphing calculator and we want to put f of x in, we want to put g of x in, and we want to find their intersection point. Now, to save ourselves a little bit of time, I've actually already done that here. All right, let me make this a little bit bigger so that we can really see it. Or let me just close it all together. You know, I mean, hey, why not? I just keep minimizing it. I don't know why. There it is, maximize. Okay, much better. So here I've got f1, right, which is 5 divided by x minus 3. Here I've got f2, which is 2 times 1 plus 3 raised to the x. I've already used my analysis tool to find the intersection point at 3.9, 5.56, right? So what is my solution? Well, keep in mind we're solving the equation f of x equals g of x, if you will, for the value of x, not the value of y, right? Because ultimately, if I have 5 divided by x minus 3 equals 2 times 1.3 to the x, there really truly is only one variable, and that's the x value. So the solution to this equation is going to be 3.9. All right, let me just kind of minimize that and put it away. And we have 3.9. Now, I do want to point out, before we move on to the third problem, that 5.6, which was the y-coordinate, is one of the choices. And that's particularly dangerous, right? But whenever you solve an equation graphically, what you are always doing is looking for the x-coordinate of intersection. All right? Always, 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 because you're solving for x. Okay, let's take a look at problem number 3. Which equation is graphed in the diagram below? All right. Well, you should have spent a considerable amount of time this year looking at modeling waves using sine and cosine functions, right? And assuming you don't have a horizontal shift, then we're going to be modeling this function either with something that looks like this, a times the sine of bx plus c, or a times the cosine of bx, plus c. Now, as a little bit of a reminder of some terminology, right, because this might be the only problem where I get to do this on, the absolute value of a is known as the amplitude of the function. That's how high and low that the wave goes above and below the midline. The midline is the c value, the vertical shift. It's also known as the average value. The b is what's known as the frequency, and we'll be dealing with that a little bit more in another problem. The reason that we don't particularly have to deal with it in this problem is because in all 4 of our choices, b is pi over 3. So I could go through and show you why b is pi over 3, but it's the same in each one of these, so it doesn't make a lot of sense to spend our time doing that. That being said, right, what I can definitely tell is that my midline value, my horizontal shift is c equals 5, right? I also can tell that my amplitude, which is not a, it's the absolute value of a, is 3, right? So in other words, this wave goes 3 units above and 3 units below the midline at c equals 5, okay? So one thing that we can do immediately is eliminate choice 3 and choice 4. We also don't really have to figure out whether a is negative or positive because a is negative on each one of these things. All right, our task really is to just figure out whether it's sine or cosine. But keep in mind, right, that sine always starts at its midline, assuming no horizontal shift, and cosine always starts at either a maximum or a minimum, depending on whether a is positive or negative. So in this case, we're starting at the midline, and because of that, this is the sine function. And specifically, it's y equals negative 3 sine pi over 3x plus 5. Now, one of the beautiful things about having 3 hours for this exam coming up is that you should never miss this problem. Not in a million years, because you have a graphing calculator. You could conceivably put in all 4 of these equations and just see which one looks like this. The key is, of course, if you're going to do that, make sure that you've got your calculator set up correctly. Okay, and by that I mean a couple things. Number 1, unlike geometry, make sure your calculator is in radian mode, all right? And the second thing that you'd want to do is you just want to make sure that you've got the correct window, right? So the window that we were just looking at went from x equals 0 to x equals 12, and I think from y equals like negative 2 to y equals 10. Notice I've put my equation in, and that is exactly the graph that I see. So there's absolutely no reason for me to get this wrong. If I put any of the other choices in there, I would see a graph that was different than the one that they gave me. All right, so don't forget that, right? Check. I would still go through the algebra, or go through the trig, I guess in this case, but then make sure that you have the right answer. All right, let me put our calculator away again. We'll come back to it. And let's take a look at question number 4. Which point is in quadrant 3 and is a solution to the system below? You know, I'm such an algebra guy that when I saw this, you know, the first thing I did was I said, okay, well, I'm going to take these two equations and I'm going to set them equal. And oh, hey, red pen came out. And then I'm going to get everything equal to 0, and I'm going to factor, and I'm going to solve, then I'm going to substitute back in to get my y values and all of that. And then I thought to myself, my goodness, I mean, we're just looking for the intersection points of these two curves. Why wouldn't you just do that on your calculator? You know, and I realize this is the third problem out of 4, right, that we're going to attack on the calculator, but there really isn't a lot of reason why you wouldn't want to do this on that. I mean, again, the algebra is not that hard, right? You're using the zero product law and all of that. But ultimately speaking, right, it's pretty easy to put in y equals x squared minus 24 and y equals x minus 12. Use your intersect command to find the -3, -15, and 4, -8. Now, one thing that's a little bit dicey in this problem is that 3, -15 and 4, -8 are both choices, all right? So right away, the choice 3 and choice 4 are out, right? They're not there. So then the issue becomes, which one of these is in quadrant 3, right? So recall, especially from the trig work that you did this year, you've got quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? Think about putting, you know, your pencil into quadrant 1 and drawing a C, right? 1, 2, 3, 4. So the one that's actually in quadrant 3 is -3, -15. And again, it's not that hard to actually solve this equation. It's relatively easy. Quite frankly, this kind of problem could now be in Algebra 1, all right? But it is just so very easy to graph both of these and find intersection points. I would argue that unless you're very, very fast with your algebra, it's actually quicker to just do it on the calculator. All right, let's take a look at number 5. For which equations will the value s equal 4 make the statement an identity? All right, so an identity, right? An identity is an equation that is always true. Meaning that if I take 4 and I plug it in, right, and let's do it for number 1 and see just what it looks like, right? If I plug 4 in for s, then that would give me 2x minus 3 quantity squared is equal to 4x squared minus 3 times 4, which would be 12x plus 9. Now, if this is an identity, then what that means is that any value of x that I put into the left side and the right side will make the two sides equal. And let me make that look a little bit more like an equal symbol, right? Now, one thing that you could do is you could actually, again, using your calculator, put this in, let's say, F1, put this in F2, and see if they give you exactly the same graph. The other thing you could do is manipulate one of the two sides to see if it's algebraically equivalent to the other side. And that's what I thought I would do. So what I'm going to do is I'm going to take 2x minus 3 and I'm going to just square it, right? So I'm going to take this thing and do 2x minus 3 times 2x minus 3. And when I do that using FOIL or whatever, I get 4x squared, and then I get negative 6x, and I get negative 6x, and then I get positive 9. So that's 4x squared minus 12x plus 9. And that is, in fact, what that one is. So 1 is most certainly an identity. All right? Let's take a look at number 2, or choice 2, or whatever, however you want to put it. Roman numeral number 2. There we go. All right. So if I put the 4 in here, then I'll get something that looks like this. X minus 2 cubed is equal to x minus 2 times x squared plus 4x, whoops, and it also has to go in there, plus 4. Now, the only way that this is an identity is if when I factor x squared plus 4x plus 4, it's x minus 2 times x minus 2, right? Because then it would be x minus 2 times x minus 2 times x minus 2, or x minus 2 cubed. Or I could work to multiply this all the way out like I did this. I'm not going to do that. In fact, what I'm going to do is just factor this. And that's relatively easy to factor, right? In fact, it factors as x plus 2 times x plus 2. It's interesting, because if this had been x squared minus 4x plus 4, minus 4x plus 4, then it would have been x minus 2 and x minus 2, and it would have been an identity. But x minus 2 times x plus 2 times x plus 2 is not x minus 2 cubed. So this is not an identity, which means it is choice 1 only. All right, let's take a look at problem number 6. The number of bacteria in a sample, which can be modeled by an exponential regression, is shown in the table below. Assuming this trend continues, approximately how many bacteria would be present 8 hours after the observation began? All right, so there's a lot kind of going on here, but probably the most important thing is that they're telling us that we can model this data using an exponential regression. In other words, we can model it with a curve that looks like y equals a times b raised to the x, but we have to use our calculator to figure that out. All right, and just like before, I've kind of set this up for us so that we don't have to spend a ton of time. All right, in order to do this on the TI Inspire, and this will be different depending on what graphing calculator you have, right? We open up a kind of a spreadsheet looking thing. I like to put time in as x and bacteria in as y. I like to actually just label those. All right, and now what I'm going to do is I'm going to hit menu. I'm going to go to choice 4 for statistics. I'm going to go to statistical calculations, right? And this is where I kind of get everything. And I see exponential regression all the way down here as letter A. So I'm just going to hit letter A. Now the reason, again, I like to label my two lists is that I can now just kind of hit this and I can say, oh, I want time as my X list. I want bacteria as my Y list, and I'm just going to hit OK. And then my exponential regression parameters are right here. All right. Specifically, I have an A value of about 40, right? It's 40.0037, and a B value of 1.19636, etc. So let me just kind of grab that data. So I've kind of got it here. And I just write that equation down. Y equals 40 times 1.196 to the x. And now they want me to try to figure out how many bacteria are present 8 hours after the observation began. So I'll do 40 times 1.196 to the 8th. I just use my calculator to do that. I won't show you how to put that in because I'm sure you know how to do it at this point in time. I get 167.459. So that is about 168. All right. So let's keep going. Here we go. Another factoring problem, number 7. Factored completely, x to the 4th plus 4x cubed minus 9x squared minus 36x is equivalent to which of the following? All right, so there's lots of different types of factoring, right? There's greatest common factors, there's difference of perfect squares, there's trinomial factoring, which we've actually seen a couple times now. And the one that should have been new in Algebra 2 is factoring by grouping. Now, if you see sort of a real kind of factor this problem, and granted we did see that in number 1, but they never used the word factor there, but it's very likely going to be a factoring by grouping. But I would still suggest that you look for a GCF, and notice x to the 4th, x to the 3rd, x squared, and x to the 1st, there's actually a GCF of x. So that's the first thing I'm going to do, is I'm going to, quote, factor that out. So all of this is equal to x times x cubed plus 4x squared minus 9x minus 36. Now, if you're saying to yourself, but wait a second, I saw the factoring by grouping first. I think I'll do that first. That is completely okay. I actually initially factored it by grouping first, and then I was like, I think I may take the GCF out first. All right, it doesn't matter. All right, now I'm going to take a look at the stuff inside, And I'm going to work on factoring that by using grouping, right? And remember, the way that we use grouping is we generally take the first two terms and we factor out what we can factor out of those, which is an x squared, and then I'd have x plus 4. And then I look at the second two terms. Now, if factoring by grouping is going to work, then when I factor something out of those two, I need to be left with an x plus 4. And very often, what you factor out is a negative number. And that's very new in Algebra 2. In Algebra 1, you almost never factor out a negative number. In this case, I'm going to factor out a negative 9 from both negative 9x and negative 36. And what that's going to look like is this. See, I could factor out a positive 9, but if I did that, then I wouldn't have an x plus 4 sitting there. And I need that, because I can now take my x plus 4 and factor it out, and all of this becomes x times x plus 4 times x squared minus 9. Now the last piece here is that my x squared minus 9 can be factored as the difference of perfect squares. I can factor it as x plus 3 times x minus 3. So I'll now have x times x plus 4 times x plus 3 times x minus 3. And that is choice number 2. And again, let me reiterate. You can definitely get all the way here by doing first factoring by grouping on here, but you will eventually have to pull this x out as a GCF at some point. All right, let's keep going. Number 8. The solution set for the equation x plus 1 equals the square root of 4x plus 25 is what? Now, right, this particular problem you definitely solve multiple times in your course, and they leave you lots of room here to algebraically solve it, right? And generally, the way that you would solve this is you would square both sides of this equation, which would leave you something like this, and then you'd have to FOIL this out, and you'd get like x squared, man, plus, and it just like, I'm just not getting 2's here whatsoever. X squared plus 2x plus 1 equals 4x plus 25, etc. All right, and then you'd set it equal to 0, and you'd find two solutions. But this is a multiple choice question. Notice the first choice is this like bracket with nothing in it. That's what's known as the empty set, meaning that there are no solutions. The second choice is x equals 6. The third choice is 6 comma negative 4, and the fourth choice is just negative 4. Now, if you have a situation like this, I guarantee that when we go through all the work of doing all of this, we're going to get two solutions, and those two solutions are going to be 6 and negative 4, all right, from this algebra. But it's very likely that one of them is going to be an extraneous root. All right? And in order to decide which one's extraneous, you actually have to check both answers. So since my only choices are 6 and negative 4, I'm just going to go ahead and check those right away. I have to do it anyway as my final step. So let me first check x equals 6. So if I take x equals 6 and I check it in this equation, I get 6 plus 1 is equal to the square root of 4 times 6 plus 25. That 7 equals the square root of 24 plus 25. That 7 equals the square root of 49. And that 7 equals 7. And that is correct. So 6 is definitely a solution. All right? Which means it can't be choice 1 or choice 4. The question is negative 4 also a solution? Let's check that one. X equals negative 4. All right, so if I do that one, I get negative 4 plus 1 is equal to the square root of 4 times negative 4 plus 25. That's going to be negative 3 is equal to the square root of negative 16 plus 25. And what I would really love is at this point, you just immediately say, nope, that can't be right. All right? And by the way, the reason that that can't be right is that this is a positive square root on this side. And what I mean by that is that there's no negative sitting out in front of it, so there is no way that this can result in a negative 3. If you kept going, right, you would get negative 3 equals the square root of 9, and that would eventually be negative 3 equals 3, and that's not a solution. So my only solution is 6. Now, I'm not going to get into the weeds with you, right, about this, all right? I have an entire lesson on solving square root equations. I think I actually have a couple lessons on solving square root equations, all right? The plain fact is, if there isn't a negative in front of the square root, then the only types of roots that you're getting out of those are the positive ones, not the negative ones. So yes, does 9 have a square root that's both 3 and negative 3? Yes. But this is the positive square root of 9, not the negative square root. All right? So the only answer here is 6. Okay, let's keep going. All right, I really like question number 9. Let's take a look at it. If f of x is represented by the graph below, which translation of f of x would have imaginary roots? All right. Now, I kind of wish, instead of the word roots here, they had used the word zeros, but zeros and roots are the same thing, all right? And they're the same thing as x-intercepts, all right? Roots, zeros, x-intercepts, all more or less the same thing. So the question is, which one of these things would result in imaginary roots? Well, right now my roots are roughly, let's say, negative 1/2 and 1, 2, 3, 4, 4.5, whatever. You know, they're real, right? F of x plus 5, that shifts everything to the left 5 units, all right? But you would still have real roots. F of x minus 5, that would shift everything to the right 5 units. And again, that would be fine. F of x plus 5, well, that would shift everything up 5 units, and it would result in something that would look like this. Now again, we have to assume in this situation that what we see on this scale is just a scale that goes by ones. I wish they would have put some indication of their scale on here. They didn't, but we have to assume that. So if we shift everything up by 5 units, notice now that what I assume is a parabola misses the x-axis entirely, which means it cannot have real roots and must only have imaginary ones. All right? So this transformation shifts that parabola up. If you will, it would give it a negative discriminant value, and suddenly your roots end up having like an I in them. Okay, let's keep moving. Talking about I, number 10. The solutions to the equation 3x squared minus 4x plus 2 equals 2x minus 3 are which of the following? And basically, all of these answers have I in them except for choice 3. And even that one, right, implies you're going to be using the quadratic formula here. Okay? So the first thing we have to do in order to use the quadratic formula is get our equation in the form ax squared plus bx plus c is equal to 0. Right now it's equal to 2x minus 3, so my first step is actually going to be to subtract a 2x and add a 3 to both sides. All right? So that's going to give me 3x squared minus 6x plus 5 is equal to 0. So that is my absolute first step. Now you could try to solve this by completing the square, but I beg you not to. Okay? I don't think you want to do that. It's not terrible. You know, I would go quadratic formula. All right. So what is the quadratic formula? The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is going to be then negative 6, which is positive 6, plus or minus the square root of negative 6 squared minus 4 times 3 times 5, all divided by 2 times 3. And watch out for that. It's very, very easy to not realize here that the a is equal to 3. So sometimes with the quadratic formula, it's very easy to just assume that the denominator is going to be equal to 2 because a is equal to 1. All right, we want to be very, very careful, and we want to evaluate that discriminant to make sure that we have that right. But of course, we can always just take out our calculator. This time I actually have to just add a new page. All right, we're going to add our calculator in. What did we have? We had -6 squared minus 4 times 3 times 5, I believe. Yep, that's right. And that's -24. Now, we kind of expected a negative discriminant, right? Because 3 of our 4 choices involve the imaginary number I. All right, but let me get that -24 in there. So we're going to get 6 plus or minus the square root of -24 all divided by 6. All right. Now, we've got some work to do. All right, we need to simplify this radical, and it's a bit ugly, all right? But let me kind of do this. 6 plus or minus the square root of -4 times the square root of 6, all divided by 6. And that's going to be 6 plus or minus 2i times the square root of 6, divided by 6. Wow, and we just keep going. Now, we're getting there. We're close to being done. But notice all of these are kind of in the form of a real number, right? 2/3, let's say, plus or minus another real number times I. So what I'm going to now do is I'm going to take this thing, and I'm going to use up some space reserved for number 11, and I'm going to rewrite it as 6 divided by 6 plus or minus, and then I'm going to move that I like this. Actually, maybe I'll move it all the way out here, right? These can simplify, dividing to give me a 3. This can simplify just to give me a 1. And that's going to be 1 plus or minus the square root of 6 over 3i. And let's take a look. Which one is that? Here it is. It is choice 2. That's it. It's kind of a beast of a quadratic formula problem that involves imaginary numbers, because not only do you have to deal with the fact that there's imaginary numbers in the quadratic formula, you also have to get everything equal to 0. You also have to simplify a radical that is not like a nice perfect square or anything like that. All right, let's keep going and take a look at number 11. A culture of 1,000 bacteria triples every 10 hours. Which expression models the number of bacteria in the sample after t hours? Okay, so what I like to tell people on a problem like this is to start by being very basic, right? The most basic exponential function here would be one that would look like this: 1,000 times 3 raised to the n, where n is simply the number of triples, if you will. Right, the number of times we've tripled the population. So we've tripled the population 1 time, 2 times, 3 times, whatever, right? But it's definitely 1,000 times 3 to the number of times we've tripled, all right? Now, how many times do we triple? Well, we triple once every 10 hours. So that means that I can calculate the number of times I've tripled by taking the number of hours that I've gone and dividing by 10. And think about that for a moment, right? If t is equal to 10, then the number of triples are 1. If t is equal to 20, then n is 2. If t is equal to 30, n is 3. Most certainly, n is not 10t, right? That's what we would get if we were tripling 10 times every hour, right? But now we're tripling 10 times, once every 10 hours, and so this entire expression becomes 1,000 times 3 to the t divided by 10. And that is choice 4. And don't worry, for those of you disappointed that it wasn't choice 1 with the E, we're going to see E plenty in this exam, especially in the free response problems. Let's take a look at number 12. An initial investment of $5,000 in an account earns 3.5% annual interest. Which function correctly represents a recursive model of the investment after n years? Now, this one's a little bit of an obnoxious problem because, right, there are 2 completely valid ways of modeling this in terms of the choices, right? But only one of them is a recursive model. So a recursive model is one that basically says, okay, this is what I have year 1, all right, or this is what I have to start with. And then this is how each year depends on the previous year, right? So, right, number 1 and number 2, or number 3, sorry, choice 1 and choice 3 are not recursive models. They're what are called explicit models. They're models where, you take the number of years, you plug them into the equation, and boom, here's how much the investment is worth. All right, so it's either choice 2 or it's choice 4. Now in both of them, we have this original value of 5,000. This one says then every year we take the previous year's amount and we multiply by 0.035, which seems decent because it's 3.5% annual interest. This one says for every year we take what we had the previous year and multiply it by 1.035. And that is our winner, right? It's choice 4 and not choice 2, because choice 2, this expression would just be calculating how much interest I've earned, not how much money I have, right? Just how much interest I've earned. This is how much money I have because I have the 100% I started with plus another 3.5%. So be very, very careful on that, especially if you see something that says a recursive model, all right? And again, it's a little bit unfortunate because choice 3 is a perfectly good explicit model. So if you read this really quickly and you're just like, hey man, which of the following, represents the amount of money we have after n years, choice 3 seems perfectly legitimate, right? The problem is it's not a recursive model. So this is as much of a vocabulary problem as it is a math problem. Well, maybe it's a little bit more of a math problem, but it's also vocab. All right, exponents, number 13. Which expression is equivalent to 2x times y squared times the cubed root of x squared times y? All right, so you probably got tortured for at least a few weeks by exponents and exponent laws and things like that. And here's the one problem on it, all right? So let's take a look. And let me write this thing down so that you can see it a little bit better. What we've got is we've got 2x y to the second times the cubed root of x squared y. Now the first thing I'm going to do is I'm going to rewrite that cubed root as a 1/3 power. All right, so I've got 2xy squared times x squared y to the 1/3. Now, we have an exponent property that says when I have a product raised to a power, that power gets applied to both parts of the product. I also have another exponent property that says when I have something raised to a power, like x squared, raised to another power, like 1/3, I multiply those two powers together. So all of this becomes the following. 2x, let me try to get that, 2x y squared times x to the 2/3 times y to the 1/3. Well, that almost looks like the parentheses is just around the 1/3. Let me do that. All right. And now I can use an exponent property that says when I multiply two things of the same base, I add their exponents. In other words, I'm going to have 2 times x to the 1 plus 2/3 times y to the 2 plus 1/3. And again, if you don't particularly feel comfortable with fractions, feel free to add the two fractions, 1 plus 2/3 and 2 plus 1/3 on your calculator. I'm going to do this really quickly in my head. 1 is the same as 3/3, so 3/3 plus 2/3 is 5/3. So that's going to be 2 times x to the 5/3. And then 2 is equal to 6/3, so 6/3 plus 1/3 is 7/3. So that's going to be y to the 7/3. After a while, thirds just sounds funny coming out of my mouth, and so we get choice 1. Seriously, you ever say a word over and over again, then it just starts to sound funny? There's a term for that in psychology, and I don't know what it is. All right, let's take a look at problem number 14. Which statements must be true about the polynomial function k of x equals negative 2x cubed minus 11x squared minus 12x plus 9? All right, so choice Roman numeral 1, x minus 3 is a factor of k of x. Number 2, k of 0 equals 9. Number 3, k of x divided by x plus 2 has a remainder of 5. 5? Yes. All right. Now, one thing that's a little bit weird about this is we're going to see a problem that basically covers on exactly what choice 3 is a little bit later on in the multiple choice. So they got a little bit redundant there. But this is really a piece about, how do polynomials work? So let's first attack, is x minus 3 a factor of k of x? Well, one way, the best way to determine that is to see if k of 3 equals 0. If k of 3 equals 0, then what's known as the remainder theorem tells us that x minus 3 is a factor of k of x. And this brings us to the first time where I'd like to use the calculator to evaluate a function. All right? So I want to use the calculator to actually evaluate this rather complicated function, all right, when x is equal to 3. So let me just grab my cheat sheet here. All right? So this is how I like to do this on the calculator. I like to use what's called the store function. All right? And store is right above the var button. And it's a little bit hard to see, so I'm gonna try to make my calculator a little bit bigger. And what I'm gonna do is I'm gonna take 3 and I'm gonna store it in the variable x. Now, right now, the calculator, at least on this screen, thinks that x is equal to 3. Right? And I can prove that to you by doing, like, if I put in x plus 2, it tells me 5, right? Because x is equal to 3. The beautiful thing is I can now type in my polynomial and see what it's equal to. So my polynomial was negative 2x to the third, all right, minus 11x squared minus 12x plus 9. And that's equal to negative 180. Now, what that tells me right now is that 3 is not a 0 of this polynomial, which means x minus 3 cannot be a factor of this polynomial. All right? So let me just kind of minimize it and put this away. So this is not the case, which means 1 is not true. Now, choice 2. K of 0 equals 9. Well, in a polynomial, right, the y-intercept, which is the value when it's equal to 0, is the constant term. And it makes sense. If I put 0 in, that goes away, that goes away, that goes away, and I'm left with 9. So that's an easy one, right? That's definitely true. Now let's talk about choice 3. When I have k of x divided by x plus 2, does it have a remainder of 5? Now, you should have done something in this course called polynomial long division, which takes a while, all right? And we don't want to do that right now because this really isn't about polynomial long division, it's about the remainder theorem. And there's this thing that says if I take some polynomial, f of x, and I divide it by x minus a, then I will always get another polynomial, whoops, plus a remainder divided by x minus a, and that remainder is always f evaluated at a. That was a lot, right? But that is what's known as the remainder theorem. And again, we're going to see it later on in multiple choice, which is weird because this is exactly what this is testing. So what I have to do, and I know that's x plus 2, not x minus 2, is I have to evaluate what k of negative 2 is, all right, and see is it equal to 5. And if k of negative 2 is equal to 5, then when I divide k of x by x minus negative 2, i.e. x plus 2, then it will have a remainder of 5. So let's use the trick that we just saw. And what I'm going to do is I'll maximize it. And I'm going to put negative 2 in now for x. Come on. There we go. And I'm going to just go up until I get my expression. And I'm going to hit enter. And I get 5. And that means that this polynomial, when divided by x plus 2, i.e. x minus negative 2, it will have a remainder of 5. All right? Known as the remainder theorem. You probably spent all of one period on it, but it takes up 2 multiple choice questions. So that's also true. So choice 2 and 3 are correct. All right. Let's take a look at number 15. To prepare for lacrosse tryouts, Cole is increasing the amount of time he spends at the gym. This week he is spending 150 minutes there, and he plans to increase this amount by 2% each week. The amount of time in minutes that he plans to spend at the gym t weeks from now is given by the function a of t equals 150 times 1.02 raised to the t. In terms of daily growth rate, the amount of time Cole is planning to spend at the gym can best be modeled by the function what? All right, so this is what I call a change in the time scale. Now, one thing is very, very true though in these types of problems. If t represents the number of weeks, then it still represents the number of weeks here. So I'm talking though, somehow I have to get the daily growth rate in. Now we all know that there are 7 days in a week, right? So we're kind of shrinking to a smaller time scale here. Now, they could have gone the other direction. They could have gone from weeks to a year, which means that we would have gone kind of like a bigger time scale. But we're going to a smaller time scale, all right? Whenever you do that, you're going to like raise this rate, right, to 1 divided by whatever that time period is. So there's 7 days in a week. So what I'm going to do is I'm going to do a little manipulation. I'm going to do 1.02 to the 1/7, and then I'll have that raised to the 7t. All right, remember, I can't actually change the function. I just want to change the way it looks, all right? And since 1.02 is the weekly rate, if I take the 7th root of it, I'll get the daily rate, right? If I raised it to, let's say that there were 4 weeks, exactly 4 weeks in every month. A month has to be the most irritating time scale on earth. But let's just say for a minute that there were exactly 4 weeks in a month, and I wanted the monthly time scale. Then I would have 1.02 to the 4th, and then I'd have 1/4 t here, all right? Because that 1/7 and 7 would just kind of cancel each other out. Now on my calculator, right, I would put 1.02 to the 1/7 in there, and you know, I won't kind of go through that, because it's easy enough to do it, and it gives me 1.00283 to the 7t. All right, and now by the way, keep in mind, right, t is the number of weeks you have, so 7 times t, right, 7 times t is the number of days. And that makes sense, right, because if I've got my daily rate raised to the number of days, then the model makes sense. So where is that particular one? It's right here. All right. Now, side note, you know, one thing that you could do in a problem like this, and again, you have 3 hours, lots of time, is you could take each one of these 4 and graph them compared to the original function, right? Because it's the same function. The question is, right, is it like based on the daily rate, all right? And all the rest of these functions are not the same function as this, okay? So let's keep going. All right, number 16. Mr. Zachary posts review assignments on the Beta Math website for his students. On his last test, 49% of his students used Beta Math and passed. All right. Overall, 68% of his students used Beta Math. Approximately what percentage of Mr. Zachary's students passed, given that they used Beta Math? All right. So this is what's known as a conditional probability problem. Okay? And you know, your teacher probably laid it out in many different ways. And there are easy conditional probability problems and there are harder ones. All right, there's a technical formula that says, all right, the probability that we pass, given that we use Beta Math, is equal to the probability that we passed and we used Beta Math, all divided by the probability we used Beta Math. But this is kind of an obscure formula, you know, and it's a little bit tricky to think about, right? So consider this. Like, let's say Mr. Zachary had 100 students. Let's say he had 100 students, right? Exactly 100. And it doesn't matter. We don't know how many students he has, so we can just kind of make up any number that we want, right? So let's just say that he had 100 students. What that would mean is that 49 of those students used beta math and passed, right? And you can see the Venn diagram, right? You know, you got this Venn diagram. You know, let's say that this is the beta max category and this is the passed category, right? And 49 of the students, right, used beta math and passed. There are 49 that are sitting in there, right? Overall, 68% of his students used beta math. So inside of this entire circle, right, the entire circle is 68 students. All right, so that's the whole circle of B. And I don't really care what's over here and I don't care what's out of there. Because as soon as I say given that they used beta math, then that 68 is in the denominator. And in the numerator, we've got the 49. And then I just take my calculator and I do 49 divided by 68. And I get 0.7205, etc. And that is about 72%. All right? And that's that. Let's take a look at problem 17. Given sine theta equals 7/25 and theta terminates in quadrant 2, what is the value of tangent of theta? All right, great. So sine theta is 7/25 and theta terminates in quadrant 2. What's the value of tan theta? So one of the things that the standards are very clear on is if you're given the value of sine or cosine and you're given the quadrant that the angle terminates in, you should be able to then figure out also the value of tan theta, cosine theta, etc., etc., etc. Now, one of the easiest ways to really think about this problem is actually to consider a right triangle trig. So let's say I had a triangle like that, and I put theta in, all right? And I knew that sine theta was 7/25. Well, sine is opposite over hypotenuse, right? So I would know now that that side was 7 and that the hypotenuse was 25. I could then use the Pythagorean theorem, which again, I'm not going to go through right now. You've been doing that since like 8th grade. I could use the Pythagorean theorem to figure out that length, which would be 24. Now, right now, I'm totally ignoring the fact that I'm in quadrant 2, and we'll come back to that in just a sec, okay? But let's think about what tan theta is. According to this particular triangle, right, tan theta now, which is opposite over adjacent, sorry about that, is 7/24. Okay? But in quadrant 2, tangent of theta is less than 0, all right? And that's because in quadrant 2, cosine is less than 0. And really, if we were thinking about the unit circle, all right, then the way that this thing would actually be oriented, would it be a triangle that would look like this, all right? And it would actually be negative 24 over here, 7 here, and 25 here. So the tangent of theta in this case is negative 7/24. And really, if I was doing this thing by the book, as I would say, then I wouldn't say that this was theta. I'd actually say that it was theta reference. It was the reference angle, right? And then I would have to determine the sine by considering the quadrant. All right, let's take a look at problem 18. Now, before I actually read the problem 18, I just want to say for the record, problem 18 is my least favorite problem on the exam. All right, and it's going to take a little bit for me to even justify how they get the correct answer in this. But let's take a look at it first. A family-owned grocery store in New Hartford, New York employs 49 people whose ages are approximately normally distributed, with a mean of 36 years and a standard deviation of 6.2 years. Ryan has been hired to work at this store. He is 30 years old. How many people who work at this store would you expect to be younger than Ryan? All right. Well, again, I have lots of problems with this problem. A lot of issues with this problem. Number one, is Ryan one of the 49 people? Or is he the 50th person? I don't know. Do you know what I mean? Would it make a difference? Maybe, maybe not. Now, at first glance, this appears to be a fairly simple normal distribution problem, right? It tells us that the thing is approximately normally distributed, all right? And Ryan is 30 years old, right? Now I want to know how many people are younger than Ryan. So my first instinct on this problem was to come in and let's just kind of like, let's take a look, right? I'm gonna put a new page in just so that we don't have to deal with all that stuff, all right? So I'd go into menu. I'm gonna go down to statistics, number 6. I'm gonna go into distributions, number 5. And I want the normal CDF. That's the normal distribution curve that accumulates. All right, lower bound. Well, nobody's less than 0 years old, so I'd put 0. Upper bound. Well, we want the people that are younger than Ryan, and Ryan is 30 years old. So my initial instinct here was to put my upper bound in at 29. Now the mean was 36, no question there, and the standard deviation was 6.2. And then I hit enter. Now what does that represent? That represents the percentage of the people that should be 0 to 29. All right, between 0 and 29 years old, all right, 0.12944. But I want to know the number of people. Now, should I multiply this by 49? Should I multiply it by 50? I don't really know because I don't know whether Ryan's the 50th person or the 49th person. So just for a minute, let me go up and grab this and multiply by, and multiply by 49. And let me go up and grab this and multiply by 50. Now, either way you slice it, those things say it should be 6 people are younger than Ryan, all right? And if you look at your answers, right, your answers are 17, 41, 7, and 8. Well, I'm pretty sure it's not the 17 or the 41. Now, if I'm a student taking this test and I see something like 6.34 or whatever I had, I'm going to go with the closest one, which is 7. So I was like, that just, neither one of them round to 7. And it's not one of those issues of like, well, you should round up because you can't have a fraction of a person. You can't, by the way, unless they're a very unfortunate person, right? So, you know, my instinct would to go with 7. Now, I looked it up, and the correct answer here is 8, all right? Now, how do you get 8? Well, the way that you get 8, right, is instead of doing this normal distribution, right, you go 0 to 30. And if you go 0 to 30, instead of 0 to 29, and then you take this and you multiply by 49, or you take this and you multiply by 50, either one, although I still think it's a little ambiguous, you get 8. Now, the reason I really dislike this question is I don't think that they should have the 7 and the 8, right? Maybe you put down 8 and then 12, maybe you have 3 and 8 and 12. You don't put down 7 and 8, right? So why is it 0 to 30 and not 0 to 29? And again, I have a ton of problems with this, real problems. Not just is Ryan the 49th or the 50th person, but it's also an approximately normal. It's an approximately normal distribution. So the answer could be 6, it could be 7, it could be 8, it could be 10. All of those would be really close enough if it's an approximately normal distribution. Do better, people that write these tests. Do better. All right. But then the other thing is, why is it 0 to 30? Why is it not 0 to 29? Well, this is the way I would reason it out. if I'm the person who's creating this test. If you think about it, right, so a normal distribution is really not supposed to be for something that's discrete, like an age. Because an age really is discrete, right? When you ask what your age is, unless you're like less than 10 years old, right, you're almost always like, well, I'm 42, or I'm 39, or I'm 25, right? If you're less than 10, that's when you're like, I'm 9 1/4, right? But typically, right, we would say that everyone that is anywhere from being born, let's call that 0, all the way up to 29.9999999, right, those people are all younger than Ryan, who's at least somewhere between 30 and 31, right, in terms of actual years that the person has been on this planet, kind of thing, right? And because of that, I think it has to be 0 to 30 instead of 0 to 29. All right, again, I just so dislike this problem. There's no way they should have a 7 and an 8 there. I'm comfortable with the idea that it should be 0 to 30 because everyone from 0 all the way up to just before you touch 30, right, should be included as people who are younger than Ryan. And that certainly, whether Ryan's the 49th person or the 50th person, would result in about 8 people that are younger than him. But, there could easily be about 7 people that are younger than him too, right? Or 6. And it would still be approximately normal. So I don't love this question. I've never seen one that's this sort of ambiguous, if you will. It is what it is. All right, anyway, that's my biggest pet peeve. I'm sure there'll be some other problems that I'll rant about, but I really dislike that one. We're going choice 4. All right, number 19. For the function d of x equals the cubed root of x plus 2, the inverse function d inverse of x equals which of the following? All right, well, I certainly have no issue with this particular problem. This is a standard find the equation of the inverse. I bet many of you could probably just sort of reason it out. But the way that you almost always solve for the equation of an inverse is you take the function and where there's a y, so to speak, you put an x, and where there's an x, you put a y. So my first step in this particular problem is I'm going to replace this thing with x equals the cubed root of y plus 2. All right? And this literally is the equation of the inverse. It's just not been solved for y. So how do we solve it for y? Well, what's happened to y? We've added 2 to it, and then we've taken the cubed root. We have to undo that by doing the inverse operation. So the first thing I'm going to do is I'm going to cube both sides. That'll give me x cubed is equal to y plus 2. And then I'm going to subtract 2 from both sides, and that'll give me x cubed minus 2 is equal to y. And so d inverse of x is x cubed minus 2. And notice how this function really does the exact opposite of this function in the opposite order, right? This particular function adds 2 to the input and then takes the cubed root. This function cubes the input and then subtracts 2. All right. Number 20. I don't love this problem either. Number 20. F of x equals x to the 4th plus x cubed minus 3x squared plus 9x minus 108, and f of 3 is equal to 0. Which values satisfy f of x equals 0? All right. I'm not entirely sure what they want you to do here. All right. Now, there's some algebra that will get you to the right answer, okay? But it's a beast, okay? And I have a hard time believing that they actually want you to do that algebra. I'm not sure, but maybe they do. All right, one thing I can tell you for certain is that as soon as you see f of 3 equals 0, then one of the values that must satisfy the equation f of x equals 0 is x equals 3. All right, so if there's any choices up here that don't include x equals 3, you can't pick them. All right, so this one's out and this one's out. Now notice, choice 1 has -4 and 3 only, and choice 3 has plus or minus 3i, -4 and 3. All right, so sort of just by reasoning, -4 and 3 have to be correct. And if you graph this, you would see that it crosses the x-axis at -4 and 3. Now the question becomes, are 3i and -3i also solutions to this equation? And that's where the algebra would get really hairy. Now you could kind of do it, right? All right, but you'd have to do some polynomial long division, and you'd actually have to do it a couple times. You'd have to divide this polynomial by x minus 3, and you'd have to divide this polynomial by x plus 4 to figure out a final quadratic that you could then use, I don't know, like the quadratic formula or something on to figure out if it's got imaginary roots. But let's try that store command on your calculator again. All right, let's take a look. Because the store command is perfectly happy, even if you don't have your calculator in any kind of complex mode or anything like that, your store command is perfectly happy. So I'm going to take, and I'm going to put 3i, and I'm going to store that in for x. Okay? And then what I'm going to do, oh my goodness, I'm going to really, it just keeps, oh my goodness. For some reason, the calculator just does not, there we go. Now I'm going to type my polynomial in. Here we go. X to the 4th, all right, plus x to the 3rd, minus 3x squared, plus 9x, minus 108. Enter. And it's equal to 0. Look at that. So 3i most certainly does satisfy that equation, that f of x is equal to 0. Now pretty much, if you've got one imaginary number that satisfies, then its opposite, its negative opposite, will also do that. It will also satisfy it. But, right, and really that's our only choice. But you can do the same thing. You could do -3i and store that in for x. And if I went up and grabbed my polynomial again, it would also be equal to 0. So both 3i and -3i also satisfy that equation, and therefore all of these choices are correct. Now again, I really kind of would love to sit down with the person who designed this question and say, what are you trying to test there? I don't think that they're trying to test the store function on the calculator. I really don't. But the algebra to actually do this problem is a bit of a beast. So I'm not sure. But don't forget that store function. It's awfully handy, and we've already used it a couple times on this test. Let's take a look at problem 21. The profit function p of x is found by subtracting the cost function c of x from the revenue function r of x. Which function below represents the cost function given that p of x equals -15x squared plus 600x plus 60, and r of x equals -0.4x squared plus 130x plus 1200? All right, so this is kind of a little bit of a decimal nightmare, and whatnot.